So welcome back, everybody, and apologies that was quite a short break, but I hope you have had the opportunity to maybe get up and stretch your legs a little bit, or maybe go and grab a coffee or something like that. But welcome back here now to the main stage, and we're going to move forward with the program. And it is now my absolute honor to welcome our next keynote speaker for the event. So it's the fourth keynote presentation of the event. And I am delighted to welcome to the stage Professor Ibrahim Kadi, a member of the board of directors of STC. So Professor, welcome. We're delighted to have you with us and really looking forward to hearing what you have to say. So the floor is yours.
Thank you very much, Dan. Welcome, everybody. Good morning or good day or good evening, wherever you are. This is actually the first experience for me talking to the world. I used to talk in a room or in a auditorium, but this is the first time I talk to the globe. So welcome, everybody. Let me start by saying that I appreciate the organizers, my friends and colleagues at the CITC and ITU. And I am intentional in saying friends and colleagues because I used to work for CITC, and I also worked for ITU. Most of my career was actually in the university and academia, where I was a professor of electrical engineering and communication and taught courses in electromagnetics, radio waves, and spectrum management. Now, of course, I am in the industry, but I feel I'm back home with the regulator. Today, I'm going to talk about spectrum for 5G and beyond. My presentation will be more generic. I'm not taking a stand. I'm talking with different hats: academia, regulator and policy, and of course, industry. So next, please. I'm going to these topics. One is I will give a quick introduction. After a few slides, I will talk about 5G in general, and then I'll talk the spectrum bands, especially the millimetric waves that are going to be open or were identified by the recent WRC. And then I'll talk about the industry challenges and regulatory solution to alleviate some of these challenges. Next, please. Well, spectrum, I think, can be beautiful. It can certainly be romantic. But more importantly for us is that it's useful. Beautiful spectrum, of course, is the rainbow, where we see the visible arc, the different colors of the lights in different spectrum, in the visible spectrum after rain, when the sun shines through the rain. And luckily, we've been lucky in Riyadh that we had some rain the last week, and some of us may have seen rainbow there. So this is the beautiful spectrum. In Arabic, though, spectrum is at-taif. At-taif in Arabic means the spectrum of frequencies, but it also has a romantic meaning. It's the mental visual image of the beloved. And many poets and writers write about at-taif in terms of its romantic connotation. So this is the romantic spectrum. However, of course, today we are addressing the useful spectrum, which is the radio spectrum, the wireless carrier of information and human intelligence, and the key enabler for the information society. So on the radio spectrum, next please. The radio spectrum is part of the electromagnetic waves, of course, that extends from 0 to infinity. It's a resource, of course, valuable resource, scarce resource, but it's also unique among other natural resources. Unique in what sense? There are many senses. I can say, first of all, it's invisible. Many people are not even aware of it. Of course, not the community that I'm talking to now, but you ask in the street, many people wouldn't know what you mean by spectrum and why is it a resource. It's limited, yes. The radio spectrum extends from about 50 kilohertz until about 300 gigahertz. So it's limited, yes, but it's not exhaustible. It's not consumable. When you use it, you don't consume it. It's not like food. You eat it and it's done. Or like oil. You burn it and there is no more oil. It's always there, the same amount all the time. But it's wasted if not used. If it's not used at all, then it's basically a resource that you're not making use of. So it's wasted. Or if it's poorly managed. And that's what's put burden on spectrum managers, of course, to make sure that spectrum is efficiently used for the benefit of humankind, especially for the socioeconomic benefits of the society and countries. The spectrum resource is subject to pollution. What's different kind from pollution that normal people know, common people know, it's basically electromagnetic pollution. If the spectrum is not managed and everybody transmits, then there will be interference, of course, and noise and jamming. All these are pollutant to the spectrum that makes it useless. But one of the other unique characteristics of this spectrum is that it's not owned by one nation or one country. It's rather shared by humanity. And this what necessitates international coordination. In terms of international coordination, harmonization, and cooperation. This is done usually through the ITU, specifically the ITUR sector of the ITU, and also by the World Radio Conferences, which is outcomes considered an international treaty. Next, please. Now, one of the major uses of the spectrum as we know it is, of course, the revolutionary mobile applications. The growth has been phenomenal over the last 30 years or so. If you see the development throughout the years of the number of subscriptions, currently we started from back 30 years ago with nearly zero users of mobile services. Now we have more mobile subscriptions than peoples in the world. Not to count the Internet of Things, where there are machine-to-machine mobile interaction. Back in 1980s, there was the first generation, which was analog. Then, with 1991, was the GSM and other second generation technologies. Then the 3G, the third generation, came around 2000. And then the fourth G that was started operation nearly 8 years ago. What a quick change. Now we are entering the fifth generation, which promises revolutionary services compared to other existing generations. Next, please. So we said that spectrum is limited. Actually, spectrum shortage is the single most critical factor affecting growth and performance of radio services, especially public mobile radio. Up till last year, there was very limited spectrum for mobile services, less than 2 gigahertz. while the sub-1 gigahertz frequencies were mostly allocated for non-mobile sources, especially broadcasting, and especially analog TV broadcasting. But even above 1 gigahertz, from 1 to 6 gigahertz, allocations were limited. The last year's conference, WRC 19, was actually a breakthrough. It opened a large amount of spectrum, especially in the millimetric wave, above 20 gigahertz. So many subbands were allocated to mobile, over 17 gigahertz in total. But the most important thing there is that out of the 17 gigahertz allocated, 14.75, about 15 gigahertz, are harmonized globally, which is very critical because spectrum waves cross borders, although the millimetric waves is short range, so it wouldn't usually go large distances. But around the borders and in small countries, it can be a problem. But harmonization is important from another aspect. That is roaming. That is economy of scale, because all handsets and user equipment will be working in those bands, and you can go across countries, and also you can buy large scale because of mass production of these needs. So harmonization is extremely critical, and it was done successfully last year in the World Radio Conference. One of the problems, I would say, is that because of the high demand for spectrum, the value of the spectrum and the price went up. But this is putting a burden on investment, because if you pay so much money just to get the spectrum, you wouldn't have enough money to invest in building the network that will use that spectrum. It's a dilemma, really, especially for investors and network operators. But basically, this is the basic law of economics. This is a limited resource and growing demand, so the price will go up. I think we have to strike a balance between this economic principle and the financial needs to invest in building networks and rolling out services. So the challenge for spectrum managers is to maximize spectrum utilization efficiency and strike a balance between the limited supply and the increasing demand, to make sure that we do have the best and the most efficient use of the spectrum. Next, please. Next, I will just 2 slides on 5G, just to explain the concept for everybody. 5G, or what's standardized under IMT 2020 by the ITU, has very aggressive targets for performance in terms of peak speeds and user experience speed and number of connections and latency, which is the airtime it takes between the air interface between the user and the network. And the target specifications are very aggressive in the 5G. Some of these specifications to attain would require the use of higher frequencies, that is millimetric waves, because in order to get extremely high speeds, you need to have high bandwidth. And high bandwidth is only available when you go to the gigahertz band, to the upper gigahertz band. So Next, please, let's talk about the use cases. We identify 4 use cases for 5G. One is the enhanced mobile broadband, high speeds, very high speeds, and mobility, and latency and low latency. Second one is the fixed wireless access, especially in the sub 1 gigahertz bands, the 600, 700, and 800 megahertz that may not allow high speeds, but it will allow wider coverage to cover rural areas and underserved areas. Then the third use cases is the ultra reliable and low latency communications, which is very important for things like self-driven cars and manufacturing, automated manufacturing, and telesurgery, and the promised things of 5G. Now, whenever they talk about 5G, it's a little hyped in terms of what can you do with it. You can't do really much things with it without enough spectrum. So if you remain within the low gigahertz, you wouldn't be able to get the extremely high speed and the low latency that are required to have things like self-driven cars or telesurgery. And the number 4 use cases is the massive machine-to-machine communications that will allow lots of sensors and other machines to communicate. This is the Internet of Things, where you can put sensors in farming, for example, or in cars, in vehicles, in telemetry, electrical utility meters, for example, and cars driving and other things that would be made possible through the 5G. Next, please. Now, let's talk about the 5 spectrum bands, the 5G spectrum bands. There are 3 main bands. Next, please. There are 3 main bands we can talk about. One is the low band. 20 years ago, we used to say low frequency, which is very, very low. Now, what we mean by low frequency here is what was called UHF. Ultra high frequency was called 20 years ago. Now, in the 5G era, it's called low bands. It's basically the frequencies below 1 gigahertz. The mid band is bands are the 1 to 6 gigahertz. We said that the low band allow coverage because of propagation characteristics of the frequencies. The medium band is actually a striking balance between coverage and capacity. It can offer good coverage and some capacity. Most capacity, however, will be attained by high bands, which we used to call super high frequency. The frequencies above 20 gigahertz. But of course, propagation characteristics will limit the coverage. So again, this is another balance that the spectrum managers have to take into account. So in order to allow coverage and capacity, you have to allocate spectrum to operators both in the low frequencies and in the medium and high spectrum. Next, please. So basically 5G promises, as we said, extremely high speeds, especially in the millimetric waves, up to 5 gigahertz, 5 gigabit per second, which is, as high as the fiber speeds can go. It will also allow spectrum managers to assign larger bandwidth, high bandwidth, 200 megahertz per channel or more. And we saw yesterday a presentation by Finland, Nokia, I think, and he talked about the 5G in Finland, where he showed performance above 1 gigabit per second, but also operators in Finland were allocated up to 300 megahertz of bandwidth. And of course, the other application is the very low latency in the air interface. These are all good things, but however, in the millimetric wave, you would, because the coverage is very limited, this would require a large amount of picocells, which means higher cost of building such huge amount of picocells, which means higher capital expenditure. And this put operators in a dilemma, because you have to invest money, so much money, without justified business case. So the internal rate of revenue of return on investment is questionable. And here I think where the role of the regulator and policymakers should come to identify the pain points of investors and to simplify for them the business case in light of the fact that business is not guaranteed and return on investment is not guaranteed. Next, please. I understand that I'm running out of time, so I'll just leave the last two slides, but it's available, of course, in the presentation. The last slide, next, please, include specific recommendations regarding different topics that will make the realization of the 5G benefits possible. With this, I thank you very much and I appreciate your patience. And I hope I didn't take much of your time. Thank you.
Ibrahim, thank you so much. And yeah, we could have listened to you for a lot longer. So I'm sorry that we don't have more time. That was a fascinating insight into some of the key issues. So thank you so much. We really appreciate your time, and we really appreciate you being with us to give us those thoughts. So so thank you very, very much.
Thank you.
Perfect. So we're now moving on to our next panel, so to session 8. So the next panel is going to be focusing on enabling spectrum innovative use and allowing fair access to adjacent sectors. So looking at fair access to spectrum and spectrum sharing. So that said, I'd now like to close this session, but we're going to be back in around about 30 seconds once again. The next session will be starting immediately here on the main stage, so please don't go anywhere. Thank you again to Ibrahim, and yeah, as I said, we'll be starting again very, very shortly. Thank you.